So friends, welcome back. So in this session we are going to discuss some of the types of graphs which are being left out. Then actually this session will continue even for the next part, because in the next part only we are going to discuss important graph types, very important graph types. So now we are just going to discuss its left out types, right? So first one is cycle graph. So what is a cycle graph? So the meaning of cycle graph is, the graph is called as a cycle graph if it consists of more number of vertices. Okay, if it consists of more number of vertices with a condition that it will have edges more than 3. Okay, so we are going to construct a graph with more number of vertices, that is many number of vertices with edges more than 3, that is more than equal to 3. So that condition you must have to follow. Then another one is, while constructing the cycle graph, each vertex should have exactly 2 edges. So if these two conditions are satisfied, so then this graph is called as a cycle graph. Okay, so this is some of the example of a cycle graph. So in this we have 3 vertices. So this 3 vertices is having more than 3 edges, that is this graph has 3 vertices and 3 edges. So this condition is satisfied. Then the degree of each and every vertex should be exactly 2. So now what is a degree? So a degree is nothing but a vertex. So it is a vertex, that vertex having a collection of edges, that is a total number of edges that are connected to this vertex. Okay, so the total number of vertex that are connected to this vertex is called as an degree. Okay, so that is called as a degree. So based on this, if you see, this vertex is having 2 edges. So the degree of this vertex is 2. So if you consider this vertex, so the degree of this vertex is also 2. So this one is having 2 edges. So the degree of each and every vertex is 2. So here also if you see, from this vertex we have 2 edges. So this is 2. So for this also we have 2. So 2, 2 and 2. So if this condition is also satisfied, okay, so if this condition is also satisfied, so this graph is called as a cycle graph. Okay friends, are you all clear? Right. So now we are going to discuss 2 types of degree in this. Not only in this, commonly when you are just going to construct any type of graph, we will be having degree calculation, in degree calculation and out degree calculation. So among degree we have 2 types, in degree and out degree. So what is this in degree and out degree? So these 2 words will often come under directed graph. So for example, let me take this. In this graph, if you see, this is a directed graph because it is having an arrow marks. So how will I calculate the in degree? So I want to calculate the degree for E. So let me take E as my vertex. For this vertex, tell me what is the degree. So what is the in degree? Then what is the out degree? Okay, so for degree of E, what is the degree of E? So total number of edges that is connected to E. So I have 1 and 2. So 2 is my degree. So now tell me what is the in degree. So in degree is nothing but the edges which are moving towards E. So the edges, these 2 are edges. So the edges which are moving towards E is called as the in degree. Okay, so now for this as an example, now can you tell me what is the in degree? So among these 2 edges, this edges is moving towards. So this edge is moving towards E. So in degree of E is 1. Right. So now what is the out degree? The edge which is coming out of this E vertex is called as a out degree. So here this is the edge which is going out of E, isn't it? So this is called as your out degree. So it is 1. So like this only we are going to calculate for the future graph explanation. Okay friends. So now we will discuss what is a cycle graph and what is an acyclic graph. So what is a cyclic graph? So by the word itself we can understand, we are going to start from one vertex and we are going to travel all the vertex and we are going to reach the starting vertex. So that is called as your cyclic graph. Okay, so we should have a path in such a way that starting from one vertex, we are going to travel all the vertex and we are reaching the same starting point. That is called as a cyclic graph. So let me start from A. Okay, so I am going to visit from A to B, B to C. See, this is a directed graph. I have the path. So based on this way I am traveling. Then C to D, D to E and D to E. See, this starting and ending is also same vertex, isn't it? So this is a cyclic graph. So now you take for acyclic graph, it is just opposite. So if you start from any one of the vertex, I cannot able to reach the same vertex. So if it is in that case, it is called as your acyclic graph. So now if you see, we can start from here A. This is my starting point. From A to B, then B to C, C to D, and we cannot able to go here. So I cannot able to visit E. So that I cannot able to visit E. So the path is cut. Okay, so the path is cut. So this is called as an acyclic graph. We cannot able to reach the same place where I started. Right. So next we will go for finite and infinite graph. So what is called as a finite graph? A graph is said to be a finite if it has equal number of vertices and equal number of edges. So a graph is said to be a finite graph if it is having equal number of vertices and equal number of edges. So if you take this graph, so how is the total number of vertices? In this graph, the total number of vertices is 4. Okay, so the total number of edges is also 4. So both are equal. So this is the finite graph, right? So what is an infinite graph? So an infinite graph will have uncountable vertices and uncountable edges. We cannot able to determine what is the total number of vertices and total number of edges. It will grow without having an end. So that is called as an infinite graph. So this is an example, right? So friends, now we are going to discuss about another type of graph techniques. It is simple graph, multi-graph and pseudo-graph. It is very easier one. Okay. So what is a simple graph? A graph is called as a simple graph. It is satisfying these conditions. Okay. If a graph is called as a simple graph, meaning is it will not have self loops. Okay, and it will not be having parallel edges. Okay. So all these graphs are constructed based on the conditions of self loops and parallel edges. See, self loop, parallel edges, self loop and parallel edges having some variancy between these. So a simple graph will not have self loop and parallel edges. So what is called as a self loop? A vertex which is starting from that vertex and again ending in the same vertex. That is called as a self loop. So like this, it will not be having. Okay, so if this type is not present, then it is called as a simple graph. Another one is it will not be having this type of a path. A to C already one edge is there. Once again we will not have A to C another path. So these two paths should not be there. If it is not there, then it is called as a simple graph. If it is there, then it is not a simple graph. Okay. So now what is a multi-graph? So graph is called as a multi-graph if it is having parallel edges. If it is having parallel edges and no self loop. If it is like this, then it is called as a multi-graph. Okay friends, so now what is a pseudo-graph? A pseudo-graph condition is it is having self loop but no parallel edges. That is, it is opposite to multi-graph. So it will be like this and no parallel edges. So this is a multi-graph. Okay friends, are you all clear about these three types? Okay. So friends, in this session we are going to discuss the last graph type. It is bipartite graph. Okay. So to construct a bipartite graph, we must have to follow these rules. Okay. So bipartite is nothing but two partitions. Okay. So we are going to divide the given graph into two partitions. So we call it as a bipartite graph. Okay, so bipartite nothing but we are dividing the graph into two parts, that is two partitions. So for example, let me take this as a graph. So we are going to divide this vertices of a graph into two parts. We are going to divide this graph into two parts with the condition that each part should have only unique number of vertices, that is the vertices should not repeat. Okay, so the count may be any. Okay, so we are going to divide this graph into two parts in such a way that each set, that is each part or each set should be distinct, that is unique number of vertices should be present. Okay, so based on this we have divided. So this is set 1 and this is set 2. Based on this condition I have divided. So in this set we have three different vertices, A, B, C and D. So here we have another set of vertices which are all peculiar, it is P, Q and R. Now the next one is we are going to connect these two sets. We are going to connect these two sets by having a condition that the vertices in one set must not have edges in the same set. Okay, so this is the condition. So like we are going to connect these two vertices. The meaning is we can connect these two sets, but we cannot connect the same set. Okay, so that is the condition. So I can draw like this, I can draw like this, I can draw like this and I can draw like this. Okay, so like this I can draw, but I cannot draw like this. Okay, so this is not allowed. Okay, so that is the given condition. Similarly, from this set, okay, so this is the condition which is not used. See, like this I cannot able to connect. This is wrong. That is the condition being given. So now from this vertices I can connect only this vertex. Okay, so I will remove this as it is wrong. So I can connect like this, or I can connect like this, or I can connect like this. Okay friends, so like this, if I am going to draw or construct a graph by using these conditions, then it is called as a bipartite graph. Okay, it is a very important graph friends. Please understand how to implement it. Okay friends, so now in the next video we are going to discuss about important graphs, that is Euler, planar, Hamiltonian graphs and so on. Okay friends, so I request you to subscribe my channel and it will be a great motivation for me. Okay friends, bye and thank you.